Welcome to Macomb Community College. My name is Dave Rowland. Today we're going to demonstrate how to line hone a cylinder block to correct main bearing bore distortion. Today we've got a 350 Chevrolet already set up in the hone. And before we start honing, I'd like to talk about the preparation that went into getting this block ready to prepare. First thing we did is we cleaned the block, cleaned the caps, the bolts are clean. We've run a tap through all the main bolt holes so that all the torque that we put on the bolt gets translated into clamping force. And before we clamped the caps in place, what we did is we had to go through a process where we had to reduce the size of those bores. Because when we hone them, what we're going to do is we're going to hone them back to the original size. They were a little bit oversized to start with on number 1 and number 4. 2, 3, and 4 looked pretty good, but the 1 and 4 bores really needed correction in this block. So the first thing we did was we had to correct the caps. So how we're going to shrink that bore is by milling or taking the machine some material off the mating surface here. But on most caps, they're kind of a rough cast, and you can't count on this surface being 90 degrees to this surface. The cap grinder locates off the side of the cap. So the first thing we did was we put the cap in the grinder, and we trued up this surface. And that will allow us to then cut this surface. Your book talks about that. You have to square the cap, is what it's called. And that's also in that process. There's like a 12-step process on line boring and line honing. The first step is squaring the cap. And what can happen is if you don't square the cap and just try to take material off here and here, you may not cut it perfectly. You may cut it at an angle. And what that will do, especially if it's the thrust bearing, is now your cap is going to be angled in the block. You won't have any end thrust on the crankshaft. When you do that, because the thrust bearing, half of the thrust bearing is tilted, you won't have any end play in the crankshaft. And that's a real problem. The thrust bearing won't live very long without any clearance. So we have cut the caps, and I've actually marked the block with the amount that we've taken out of each of the positions. And we've cut the cap and then bolted it in place and measured it, and we've got about 45 10,000ths small. We've made each bearing bore about 45 10,000ths smaller than the stock or the original measurement. So now we've got that much material that we can hone out. The specification for this particular bearing bore, we can look in the Clevite shop manual, is the specification we're looking for is 2.6406 to 2.4615. And if we take out that amount, what we're going to do is we're going to end up with a minimum size, the smallest bore that the manufacturer allows. So now we set up our dial indicator that you see hanging in the hone tank to that minimum specification. All right. Now we've got the honing mandrel and got it inserted in the bore. We have to set the end stops on this particular piece because we're going to move that stone in and out of those main bearing bores, and we want the stones to travel all the way through about halfway between the two, number 1 and number 2 bearing cap, and on the other end we want it to come this far so that it will stroke all the way between number 4 and number 5. Okay? So we've already done, what was that?
That was the latch.
Oh, the latch snapped, okay. It sounded like somebody was popping bubble wrap. All right. got the end stop set. So the furthest I can pull, and the stops are here on the machine. There's one here and one here. I can't pull this machine any further back. And my stone is about halfway between the number 4 and number 5 main cap. And when I go the other way, oh, I see. We're going to be able to go so our stone is right here in the middle. That's called overstroking. See that?
Yeah, I was about to ask why you want in and out of
We want to be able to come out of these two end bores because a honing process like this is going to want to oversize this one, and it's going to want to oversize the two end caps the fastest. So these caps, because of just the way the hone works, in and out, we'll spend less time in this main bore and the far main bore because we travel, the stone will leave that bore. It won't leave these, the ones in the middle. But we're going to take material out of the two ends quicker than we do out of the three middles. Does that make sense? Answer that question? All right. Main caps are installed and they're torqued to spec, just like we would run this engine. So that means we've already loaded it up. Any distortion that's going to occur because of torquing the fasteners are already in there. And you notice I've also installed part of my oil pump because the oil pump bolts to the main cap. And it's torqued to spec. Spec 65 foot-pounds, I think, is what we torqued it to the other day. And we want to make sure that if that main cap distorts when the oil pump is torqued, that we're distorting it now and we'll hone it perfectly round. Does that make sense? Okay. We're pretty much ready to go. So at this point, I'll set my tension on the stones. That looks pretty good. And start all the way in one direction. We're going to have oil, our honing oil, same honing oil we would use in the cylinder hone, going to be flowing all over the mandrel. So it might get a little messy, a little slippery in here, and that's why I've got the rubber mat underneath my feet. Now I'm going to stop and we're going to measure. There's a lot of stopping and measuring in this process because you saw how hard I had to push that hone. I've got the tension set correctly. There's a lot of tension and this process will take material out quite quickly. So you don't want to make a bunch of passes with this mandrel and then find out you took too much material out. See the two pieces of wood? That's why they're there, so we can set this mandrel down. We take our bore gauge and we want to measure to see how much material we took out on that first pass. Now, this bore started out what's it say there? Can you see that?
0045.
0045 undersize. And now I'm I took at least a full thousandth out of there because I'm seeing 33 ten-thousandths undersized now. And we'll see what we did here too. And I've got about 25 there. Didn't I tell you we take more out on the ends? I've got about 25 there. And about 23 there. More like 32 there. So the end bore's got changed more than the center bores. Now, which way did I start the last time? We started all the way in?
I did.
We're going to start the other direction. Maybe. And we're up against the stop. Adjust the tension on the stones. I've got about 14. I'm still tight about 14 this way. Now I'm going to turn and check to see how round I'm keeping this bore. And we're still not quite as round as we need to be. I've got 14 in one direction and 15, 16, 17 in another. So I've got about 3 ten-thousandths out of round currently in this front bore. And our goal here is to make sure that we've got a bore that's round and the right size. Okay, I'm about 1/1000th on this one, which means that we took material out fast on that one. And we'll go we'll measure it at an angle. And I got about 5/10,000ths out around on that one. Measure that again. I got about 1/1000ths to go in this bore. And real close there, about 9/10,000ths to go there. And for some reason, we seem to be pretty tight. No, we've got about 2/19 to go there. $18, $19 to go.
While you're measuring right there, if you had a cap that was perfect already, you would loosen that up, right?
Yes. What we can do is, in order to stop removing material, we can loosen up a cap, and we'll stop removing material in that bore. So what we may end up doing is, at this point, loosening up some center caps. Okay. We're going to make one more pass and see where we're at. You can see that you do a lot more measuring than you do honing. What's that? Well, it takes a lot to push that thing. There's a lot of force that you got to put on that thing to make it move. And if you get oil all over the floor, which it tends to do, it makes it really, really slippery over here. That's why I got the mat. That's the third pass, right? So we're taking out over 1,000s per pass is what we've been taking, generally, every time we send that stone through there. within 5/10,000ths on number 1 main of the minimum spec. There's about 1,000, there is a full 1,000 built into the specification. I've got my dial bore gauge set at the minimum. So when I get to 0 on the bore gauge, that still gives me some more room. If I'm aiming to be in the middle of the specification, that still gives me 5/10,000ths past 0 on this gauge that I can still continue to hone. At this point, we're going to stop and we're going to flip this block end for end. We're going to take it and instead of going this way, we're going to flip the block and we're going to hone from the other direction. What that does is it allows us to keep the bores round. It minimizes the outer round by flipping it.
I'm not going to torque them down yet, am I? Just a few right now.
How far did you say you had to go west when you were doing that? What did you measure west at?
We were very close. We're right at 0 on this one. Let's see how we are for out around. Maybe 2/10,000ths out around. Yep. We're like 3/10,000ths over the 0. And we're very round. So now we're going to torque them all back down and just double check our measurements. But it looks like we're where we need to be.
What about with that one being a little out of round? Just acceptable?
Couple of 10,000ths, how much did you see when you measured your block? Yeah. And we wouldn't want to see half 1,000, but a couple of 10,000ths isn't going to make or break this line home. It's not that sensitive.
Now, does this process require a finish honing?
This is it.
Right, because the fact that it has a bearing that goes in there.
Right. The bearing's going to go on top of this surface, right? And then this is the support for the crankshaft. How much clearance do we typically see between the crankshaft and the main bearing when we put the bearings in and put the crankshaft in here? There's a rule of thumb that says that a bearing needs about 1,000 clearance for every inch of diameter. And that, if you look at most bearing manufacturers' spec and then look at the journal diameter, they're very close to that with everything. I haven't seen too many exceptions to that. So if you take a look at the Molly Clevite book for this engine, we'll see what the main journal diameter of the crankshaft is, and then I'll let you tell me what you think the specification should be for bearing clearance. Let's see. rod bearing, main bearing. Okay, the main bearing, the journal, the shaft diameter is 2.448. So if the journal diameter is 2.448, 1/1000ths per inch means we're going to have, 24 10,000ths, or 2,000ths, 0.0024 would be our clearance. Okay, looking over to the specification here, vertical oil clearance goes from 6 10,000ths to 36 10,000ths. So that rule of thumb put us right in the middle, didn't it? Okay? Well, that same rule of thumb, 1/1000ths clearance per inch of journal diameter, holds true for connecting rods. It holds true for crankshaft main bearings. It holds true for camshaft bearings as well. That's a pretty good overall rule of thumb, that if the journal, so if I have a 2-inch journal, I need 2/1000ths oil clearance. That gives me enough hydrodynamic wedge for that crankshaft to ride on. Does that make sense? All right. We're all torqued down, right? Let's measure them to see if we're done. I think we are. We already measured the number 4, or number 5. Let's measure number 4. And we are just a skosh tight. We're like 2/10,000ths tight there. Pretty round. And we're still a little tight on that one. All right, we're going to send this through one more time. We're going to decrease the pressure on the stones just a little bit so we don't take as much material. And make one light pass, and I think we'll be happy with the results.
You don't want to listen off of me on the back?
No. We're right at 0, and if we take it a little past 0, we're still within our factory tolerance. What we're doing is we're just decreasing the amount of tension on the stone just a little bit. Now, if we went too far, if we got too aggressive, what could we do to correct it? If I took too much material out on that last pass, yeah, we could start over. We could take the caps all back off, take them over to the cap grinder, shave some more material off there, and start over, and start honing. You can see that you don't want to have to go through all that. It's a lot of extra time to get it set back up to do it again. That's why you want to make a pass and stop and measure. Make another pass, stop and measure. It's amazing to me to think that we can take that much material that quickly with just one down and back of that stone.
Now, if you had to replace the main caps, if you had to do more passes, or they come fairly, I would say close, so you wouldn't have to spend so much time machining them or honing them?
And if you're replacing main caps, you would not typically be doing this process. You would be, you'd be line boring, yes. I don't think I decreased the tension, I think I increased it. So we may have to see what we did. I think I went the wrong way on the feed. Okay, moment of truth. Okay, we are 6. We're still within our spec. We're at 6/10,000ths over the 0 point, where I've zeroed the gauge. We've got about 3 10,000ths out around. Right in the middle on this one, we're about 5 10,000ths over the minimum. Now let's see where we are. Oh, is it going that way or that way? That way. Very round. Very round. Nice. Same thing there. About 1 10,000th out around there. We're like 7/10ths, still well within our spec. And about 3 out around. 3 10,000ths, that is. And we're right on the spec there. Pretty round. All right. Any questions?